right, so I'm going to get started now. Good morning again and welcome. I'm Sarah Siddiqui. I'm a STEM librarian here at Carlson Library for River Campus Libraries. And today's session is a part of our Open Access Week series, the workshops we've been doing all week. The theme this week, hopefully if you've heard, has been about preprints. So today we're going to talk about something related, but slightly different too, about your code and research workflows, and hopefully share some tips here that could help build on those. All right, so I'll start off with a brief outline of what we'll be talking about. The first thing, we can have a slight discussion of why we're talking about this workshop. Why is reproducibility important? Then share some tips for platforms that you can use to streamline your workflow. Then we can look at some tips relating to your coding and your programming, just very basic. You don't have to have a large programming knowledge, although it helps if you do, but something you can incorporate. Then we can look at some examples of moving from codes to writing reports. And finally, we'll talk about just managing your file structure and Readme files. So at any point, if you have any questions, you can feel free to post them in the chat, or if you'd like to speak out too, you're also welcome to do that. But we have some wonderful colleagues over here who are looking at that. So let's get started with thinking about why is reproducibility important. I wanted to play this video. It's a little loud and funky, but hopefully I think it sets the stage in a fun way. And I hope you can hear the sound, though it's not important. Sorry, I clicked on my computer. Should not have done that. Oh no. All right, I'll stop it over there, but I thought this was fun to just get started and set the stage. Now, I'd also like to ask you if you have some, one second, sorry. Yes, so if you have some things about why you think reproducibility is important, if you would like to, talk out, you can speak up, unmute yourself, but also post them in the chat. If there's anything in the chat, if you could let me know. All right, so while you're talking, so just when you think about it, people are talking about reproducibility. It is growing because thinking about the quality of the research, you want other people to be able to build on what you're doing and just recreate your results. And I think, as you saw in this example, in this fun video, having a good workflow that makes sense makes things easier for you as well. If there's at any point you want to make a few changes instead of redoing the whole thing or reinventing the wheel, if the workflow makes sense, if the code is easy to read, then it makes things easier for you as well. So next up, I'm also going to talk about the FAIR principles, and this really relates to this. First, this is Open Access Week, and the FAIR principles for data sharing, which talk about it being findable, accessible, interoperable, and reusable. They are very complementary to all of the open access principles too. And I'd say reproducible codes do tie in with pretty much all principles of FAIR in some way or the other, but I think it really expands on reusability in particular, because if you're hearing about reproducibility and replicability, which are kind of related things, where if you're sharing your file, if you're sharing your code or software with an article or somewhere else, people are able to recreate what you did and get the same results. Or thinking about replicability, if they work with a different data set, but are working with what you're talking about, they still get the same results and the same output. So all those tie into FAIR principles beautifully. And so you want to make sure that things you're doing are easy to use. I see a chat. Okay. Yeah, and Mariana posted the FAIR principles over there, so thank you for that. And of course, now going forward, it is a requirement by journals as well, as you are publishing your papers, submitting articles. PLOS has had these mandates for having a data availability statement since 2014, which just talked about, and that was just about how people can access your data. But in recent times, this is growing. So Nature from 2018 has been going as far as to encouraging authors to provide source code, an installation guide, a sample data set, and to make this code available to review. So that's a lot of things. And of course, as you're providing that, if you get started earlier, it makes it easy for people to use it. And then first, tying this back into preprints. See, it's of course useful because, you know, submitting papers, as hopefully you had heard during some of the earlier sessions we had this week too, it takes time to share it and make it available to the public. But preprints are an excellent way of boosting the visibility and discoverability. So even when your paper isn't done, if you want to share your work or your code at some point, you have an opportunity to get feedback from other people too, before you submit to the journal. Going forward, it allows people to build on your results. And once you're done, there have been studies which show that there is a positive correlation between the availability of code and software and the number of citations. So of course, you want something that works for everyone. It's not, you know, you don't want any hidden packages or dependencies that only work on your computer and don't work on other people's. So that's why it's just good to have these practices. All right. Now, next up, I'm going to talk about some of the platforms that you could use and incorporate into your workflow to help with reproducibility. I will start off by mentioning that this is not an exhaustive list, but just some things that you can use. And depending on what you're comfortable with, who you're working with, and the requirements in your discipline, you can use a combination or choose to use one or more of those. So when it comes to coding or programming, RStudio or R via RStudio is very common. If you're using R, if you're using Julia, Python, or R, Jupyter Notebooks are frequently used. But also recently there are options where you can use Jupyter Notebooks with other programming languages as well. So you could do C++ or MATLAB or other things. There are ways you can incorporate it. And, you know, in addition to your code, as you're going to see very quickly, you can also have comments and other things. So make it like a notebook where people can see things, but also have your code. And then Binder is a great option for interactive notebooks. So people can see it and they can also run it. Then the next is Git or GitHub. So you also saw in the video, you can publicly share your code, but it also allows you to control versions. So you can have updates and easily share it over there. As of this August, GitHub has also been providing support for software citations, which is supported by Cenoto, which I'll talk about very soon. Then we have OSF, or the Open Science Framework Platform. OSF is great for sharing data and products, but you can also combine it with your preprint and postprints. So you can have one place where you can have your code, you can have your report, and everything. The only thing is that OSF doesn't let you run the software, but you can still have all of your code and your output over there. It also allows you to set privacy settings. So if you initially just want to not share it with everyone, but have it in one place, and when you're okay with it, it's good to go for the public. You can make it visible. Also, with OSF, Crossref enables links from the preprint to the published version. And if you have stuff in OSF, if you have a publication or any material that's there, that's indexed in Google Scholar. So that's another way where people can find it, but also find any software you have associated with it. The next we have Cenoto, which is operated by CERN. Cenoto is really good for long-term preservation of your code and archiving it. You can link your software or the code and the metadata from GitHub, and it allows you to create DOIs. It also has capability for supporting embargoes. So for some reason, you don't want to share for the first 2 or 3 years, and you can share it later. So the 4 platforms we looked at right now are all open source. Now I'm talking about Figshare and CodeOcean. These are proprietary software, but they're still good and very popular. So Figshare has capabilities for sharing codes privately with your team as well. And again, you can also link software that's in GitHub or code in Figshare to GitHub for creating DOIs. It is also a repository. So once you have everything in there, and the good thing is it links to the database dimensions for grants. So if the work you're doing is funded by an organization or something, you want to show them that piece as well, there's another link. And then another platform is CodeOcean. CodeOcean offers an environment to upload and run your code and algorithms. And if something is done in CodeOcean, there are some articles where you can embed that piece of code and that software inside the journal article, in the online version, of course. But it also creates an environment where people can execute pieces of software. So that's very cool. And again, like I said, this is not a complete list. Triad is another platform that is very popular. It's a curated digital repository, and you can also partner up with Cenoto. So there are many options, and different platforms have different capabilities. So for instance, Figshare has a limit of 5 GB per file. Cenoto has different limits according to your data set. If you are using, if you're more in the sciences or biology and you're using protocols, there's the platform protocols.io where you can upload those things. So there are a lot of options. And if you have questions going forward too, you can reach out to any of your librarians and we're happy to help figure things out. All right, so next up, I wanted to talk a little bit more about version control. So as I mentioned, GitHub and OSF, they all have different capabilities of version control, which is really important and something you want to be able to do. And there's sort of 2 pieces to version control. You want to be able to track changes and updates that you're making in your code, but there's also the version control in terms of software and that dependency. So, I mean, of course, with Python and R, as new versions come along, there are things that worked in one version, or libraries or packages that were supported. Maybe it was supported by R 3.4, but it's not as supported, or it doesn't work in the same way with R 4.1. So you want to be able to make sure that you track what versions you were using it at the time that you created your software and be able to recreate that. And there are ways you can do this. So for example, in R, there are some inbuilt packages and libraries like Backrat and Checkpoint that allow you to save versions or keep track of what you were using. There's also Docker that's very popular and used with a lot of things. There are ways you can use it with different programming languages as well. But Docker essentially is sort of a software that splits up all the packages and the libraries and environments that you were using into different places and saves an image, so to say, of it. So when you are again loading it, it reloads that image again, and you can look at what was being done. Also, there is that command session info in R, which is very simple, and I'll show it to you in a bit, but it's also good for troubleshooting. So you can type session info and see what version of things you're using right now in your environment. And based on that, see if something's missing. If someone said in their metadata or in their README files that this was done with 3.5 and yours says that it's R 4.1, then you may want to change that. And of course, like I said, these examples are from R, but you can also do things in other programming languages. Conda is good for keeping track and doing version control in Python as well. All right. Any questions at this point? I don't see anything in the chat. All right. So now I'm going to show you some examples to see what it looks like. So there is a Jupyter Notebook that I showed. I figured it's a good way that you can also see what I have been talking about, and it's not as abstract. So you can put that in the chat. Thank you. And let's see. So this link is going to take you to this page on GitHub. Sorry. One second. Not this page. I take that back. It was this page. So just as I mentioned, you have in GitHub, you can share your code and you can share different versions of your code. You can see up here that I had this file uploaded a week ago. You can see the history and everything. And this is a Jupyter Notebook running on the R kernel. So you can see what I have done over here. And this is not executable, but like I mentioned, Binder is a way to have an executable environment. So you can do that. I wanted to show you an example of that. So up here, if you go and click on the folder, and this is just an option, you don't have to follow along, but I thought I'll show you the possibility. Up here, there is a link to Binder. And sometimes it takes a couple seconds, but once it's done, you'll be able to see an interactive notebook. And while that's done, I'll just show it to you on my own Jupyter Notebook so you can see what it looks like. So here we are now moving to the code and programming tips. All right, so the first thing, and I've said this probably before and I will say it again, including comments is really useful for yourself and for reproducibility of your programs. I mean, I know that sometimes, I think I remember what I've done or why I had included something or done it in a way, but I don't remember it even, a few months later, or if you think about using something, after a few years. So have comments and include your steps for why you're doing something. And then this is another tip. If you are installing any packages, generally, if you're using R or something, installation of packages is something you only have to do once. It's not something you load over and over again. It's a good idea to still include it up here somewhere and just comment it out so that it doesn't run again and it's not loading, but still you have that tracked that you had used this package. And of course, ggplot is a very basic example. I'm sure pretty much everybody uses it, but that's, yeah, it's here. So next up, you're using your libraries and different things that you're including. It's very common when people are doing longer programming languages that they include all of the libraries at the top of their code that they use at different places, which is good. It makes it easier to see what's in there. But if you're using something that's very obscure and if there's a little bit part of your code that you used it, it's a good idea to just have a brief note indicating why you use this. So, example, I loaded the library caret, which is good for classification, regression, and a lot of related things. You might have something that's, something more obscure for whatever reason. Just make a note for why you're using this, because again, going forward, if there's an issue, it helps you go back and troubleshoot it. So this is an example of that session info command that I was talking about. You see the output, it tells me that this is using the R version 3.6.1 and all of the other dependencies. You can also see what the other packages and other things are. So it's very detailed, but again, if something comes up, you can go here and see what was happening. So next up, I wanted to also talk about, meaningful names, also meaningful variable names. That makes sense to you too. It's always a good idea. So here I have the simple visualization. It just shows me a plot of x-axis and y-axis. And you don't really know what this is. Don't look at my code over here yet. But again, so you think about variable names, but also as you're showing things, you want to explain things as much as possible because it makes things easier. So up here, you can see that, oh, this was a plot of top speed against stopping distance in the car's data. Something like that. It doesn't hurt to over-explain. I don't think over-explaining is a thing. So that's the first one. And the next up, as you're sharing your codes, of course, you will be using a variety of files from your computer and your folders. It's always good that when you're sharing it to use relative file paths. You do not want to use absolute file paths because that's going to break, even if you're changing your machine or something. So you can see that there is this file, output.csv, that I wanted to load, but I gave the full address for one of my colleagues' computers. So this ran on her computer, but for me, it gave me an error that it could not open the connection. Versus if I just gave the relative file path, as you can see up here, I have this folder called Reproducibility, and this is where my file, you cannot see this. Oh, we can just assume that I have a folder called Reproducibility, and that's where the file is. So, all right. So that is going to help, and it's going to be able to run for everyone because as you're sharing your file, you can see you'll be sharing things like that and even as you are working on your README files, you want to include all of that information too. So this is the folder and any other dependencies. It's always a good idea. So the next step, you'll talk about things you can do when you're processing your data. So as obviously, if you're doing Go programming, there are going to be changes and edits that you make to your variables and your parameters. It's a good idea to keep track of what the changes are. So in your file too, again, I'm going to talk about that over and over, have a comment about what changes you're doing. So for example, here I'm loading this another data and I choose to normalize the first column, sepal length. Here with this, so you just talk about that this is what I'm doing and then save it out. So if forward you make a lot of changes to your files, you had a lot of null variables or something like that, and you chose to replace it with the median value in your column or something else, or you're deleting rows, it's good to just export that modified data and that version too, so that you have that, have your original version that's untouched, but any other changes that you're using going forward too. So another example, so if I'm working with this data over here, you can see this is another preloaded data, empty cars and R's in R, and maybe I want to do some training or machine learning of some sort, and I choose to split this into test and training data. I can go back and use this command to save this. And here it's, I guess, I know I mentioned about relative and absolute paths, and I just realized I gave the absolute path over here. So this is something, but again, I'm saving this to my computer. So here you can mention a note that this is, you can specify the full path about where you want to save it, or changes to relative paths as well. And once this is done, it creates a file in my CSV, in my reproducibility folder for the train and the test data. And also, I will talk about file names as well. It's always good to choose concise but meaningful names. As you're thinking about file naming is something you want to think about at the beginning of your programming, about what file names you want to use, what conventions you want to use. and then stick to it, because just so you can find things easily. And then the next one, you saw up here that I had used a function to normalize my variables. Again, functions are also good to make your code more concise. You can avoid duplication instead of writing, even though in this case, there were just 2 lines, but you may have to write that over and over again, especially if you have something longer. So it's good to use functions. So here I have this example for just creating the hypotenuse of a triangle using this function. So, you have different triangles and different sides. You can refer back to that function over and over again. It's also good for making any changes. So if there was something in your function that didn't work, instead of changing it 10 times in your code, you can just change it once in this function up here, and that makes things easier for everyone. And then the last one, the tip that I'm going to talk about is thinking of using random numbers. So again, for different things that you're doing, you may want to generate a list of random numbers. So this is one example where I use rnorm that just gives me a list of 10 random numbers. And this I wanted to run and show you. So I run it once, I get these random numbers. If I run it again, the numbers change, because first, that's the idea of randomness. But after a point, if you want to keep track of those numbers, you can do something called setting the seed. This is also a capability in Python too, from the random.seed library. And now, once I set a seed, every time I run it, I'm going to get the same output. The 99 is arbitrary. You can choose whatever seed you want to do, but just have that number and have it saved, so your output doesn't change no matter how many times you run it. So these were some programming tips. Any question at this point? All right. Okay. We're back to the PowerPoint. So again, this is just a rerun of what I talked about, include all the packages used in the code. Again, if you're using the R proper app, you install the packages in the console typically, so still have that included in your script as a comment. And then descriptive variable names, describe your steps. Other thing is code produces output. So also think about if you have a few lines of code, that they should be doing something that's related to your program. It's not just you calculate something and then don't use it. It's good to have it clean to avoid confusion. And yeah, this is about random values and using set.seed or random.seed in Python. Okay, so now I'm going to talk about reproducible reports. So again, we looked at Jupyter Notebooks and Binder. One second. All right. Let me see. Okay, yeah, if you could read that out.
The user mentioned that this looks for her as an advanced course if you have a recording or webinar plan for an R beginner.
For using R?
Yes.
I can share basic R resources with you later on. There are R tutorials. If you have a chance, if you've heard of carpentries or library carpentries, they have a really good beginner R tutorial to just get you started and learn about things. So I can share that going forward too. Okay, any other questions? All right. Yeah, and there is another link, that Jer shared that talks about the differences between R Markdown and Jupyter Notebook. So Jupyter Notebook is what we just looked at. R Markdown relating to R is a way that you can do reports and share it. So let me just show you what it looks like. So up here, this is an example of an R Markdown. Sorry, I lost my cursor here. You can see what a report looks like. So most of the code that I have in here, sorry, let me hide this part. Yeah, it's pretty similar to what I had in the Jupyter Notebook as well. It's just in a different environment. And it's black because I changed the colors of my RStudio, so you can always do that if you want to. And you'll see you can have text just as words using the Markdown language up here. And any of the coding that you can have in these fragments that are called chunks. So every chunk can have different pieces of code. And there are different options you can do with a chunk as well. So you can choose to show your chunk. You can choose to hide the output of your chunk. And there are a lot of different options. So I just wanted to show you what this looks like over here. And once we run this, up here is an option that you can knit it, and you can specify, so you have different options. You can knit it to an HTML, a PDF, or a Word. And up here at the top of my document, also I had mentioned that the output is going to be a PDF document. So let me show you what happens if I click on knit to PDF. And up here, it shows me how every chunk is executing. So it's running. And this is where it comes up. You can also name your chunks too. So I think because I'm sharing my screen, it's a little slow. But up here, yep, there. We have the output, and it will come up in a second. So this chunk is called plotting data up here. So if there is any error or something, you will be able to see that over here. If there's a named chunk and it wasn't able to execute, so that's another way for you to debug it. So once this is knit and all of that is done, this is what the output would look like. I can make this a little bigger. So here we have a nice PDF document that's ready to submit. If anyone's interested in something simple like this, or of course, if you're doing all of that good stuff. And like I mentioned, so for the first step, we had that piece of chunk of code. And I said that I wanted to hide my results. So I did that over here, and now it doesn't show up in my PDF. You don't see that output either. There are other things, but you can see the plots over here. And again, this line, you see, this was an error. We knew that from the previous file as well, but I went in and I told my Markdown that I do not want this chunk to, let's go there. Yeah, I said that I do not want this bit to evaluate. So a lot of options you can do. I said eval equals false, which means evaluate, it's don't evaluate. And then it's not going to show up, but I can still see the output of this that's there. So a lot of different things you can do and just have your report ready to go. Right. So next up. All right, so finally, I'm going to talk again about file management and readmes. So as you're doing all of these steps, and I know I've said this several times, it's really good to document what you have been doing, sometimes why you have been doing, what all the dependencies are and packages that you're using in your program. So your readmes could be in the file of a plain text file. It could be a markdown, just as we saw. And there are many different templates that are available for using a readme. Depending on your discipline, you can choose to adapt that or have your own system if you want. But the good thing is to have consistency. So even with file names, as I mentioned, just decide on your convention before you even start collecting your files, because you don't want to go and make changes to that. And all of that information, including licenses or anything that you want, can also be README. And as we saw in that notebook on my GitHub, you can share that, and the README just stands out. So now I have a small activity for all of you, is that I'm sure is going to share this link in the chat to create a README for yourself. So I think I'm going to give you about 10 minutes, and this template is by Cornell. Let me share this. All right. Oh, I do need to copy that 1 second. Okay. So this is a guide to creating Readme by Cornell. I really like this. They have a few other tips as well that you can look at. They talk about best practices and again, a lot of things. So also standardized formats. Yeah, this is something I didn't mention, I think, but date and time. And of course, this is something that comes up as you're processing your data. And I'm sure you'll see different CSVs. They have different formats and merging that is annoying. So at the beginning, decide what format you want. And it's good to mention that in your README. So here they have a few recommendations to have a title, your institution, licenses or restrictions you have. I think a lot of what I talked about was relating to the methodological information. So what methods you use for data collection, what you use for data processing, any software or specific information to mention that too. So up here, they have a template that you can download. So, all right, so here's our activity for today. I want you to save this on your computers and think of any data set that you have right now that you're working with or you've come across, and try to fill as many fields in this document as possible. And, and then share your thoughts out here. So let me know what you think. All right. I'm going to stop sharing now so I can see you, and hopefully if you're working on it, you can let me know what you think. And if you have any questions at this point too, we can share that and put them in the chat, and questions about filling out the README as well. Also, if you want a suggestion for a data set, let me know. I can share that too. So do you have consulting sessions if I develop our analysis based on Excel database file? During those sessions, I can try to help you. If you want, you can set up an appointment with me. We can think about that. We used to do a few introductory workshops, but yeah, you can reach out and we can try to help you with basic people, whatever works. So I'll put my email in the chat, and I'm going to show that on the slide as well. Yeah. So would anyone like to share if they're working on creating those templates, how it's going? Mariana, I'm going to ask you, since you're here, if you've had a chance to look at that template before, if you want to share anything. Okay. Okay. Not working on it. Give another minute if you are working on it, and if you want to share something. If you're not working on it, that's fine. You can go back and look at it. But why don't I show this to you? It's more. Yeah, I really like this as well, because I mean, of course, depending on your field, there are different standards, but it touches on a lot of different questions, and it sounds like a lot too. Like this is a lot of things to work on, but believe me, if you have this done in the beginning, if you have an idea of all of these areas, once you are doing your code or your workflow, it makes things so much easier at the end. So yeah, I highly recommend using a README, and yeah, I don't think there's anything like too much information or anything, different places, it just renders differently. And oh yeah, also, since we're here, that binder link, I had forgotten about this, but it did execute, so hang on. And now it went away. Oh. Yeah, that's fine. So we'll see. Sometimes binder works really quickly, and at other times it takes a while, but it's another way that you can share your code. And here it shows it's pretty similar to what it was in GitHub. This is not executable, but you can see the different things that people have done. And once it loads, if it loads in the next minute or so, I can show it to you. But aside from that, yeah, we are done talking this point, but I kind of wanted to open this up, and we use the last 5-10 minutes for you to ask any questions, but also if you have any suggestions from your or any best practices that you have that you would like to share with the group, that would be really great too. So feel free to unmute yourself or type in the chat, what's easier, and any tips you thought of. Yeah, and yes, okay, all right, this loaded. So we have our binder that we can look at too. So once the binder runs and this is an executable environment, and you'll see that just changed up here to the R kernel. Jupyter is obviously more commonly used with Python, but here, if you go in, you have the option of going up here and loading everything. And I had to install Carrot because I didn't install it from the right place, but yeah. And this is, again, actually, it's a good test for why wasn't this working over here, because I did not include it, or I did not execute my code in order. So as I ran this here, we have a slightly different version too. So I think that's good to look at. Keep an eye out on things. So there are many ways you can use your notebooks, and many options. Just going back to the platforms that we've talked about. So yeah, whatever you're more comfortable with, we can use. All right, so I am going to stop sharing over here, and this is mostly it. So yeah, feel free to hang out and share your thoughts and any ideas. The slides, yes, I think we have to figure out how to exactly one place where we'll be sharing it. But yes, we can share the slides, and we'll be uploading sharing the recording of the session as well. So watch out for that. Thank you, Chang. All right, and as Sarah reminded us, if you're registered, make sure you did, and you will get a link soon. And if there's any trouble, you can, my email is here as well. Send me an email or reach out to any of us. But yeah, so thank you, Sarah. So yeah, if there are no other questions, I'm going to hang out here for a while and I'll stop recording in a minute. But this was just a few tips for reproducibility as part of the Open Access Week organized here at the River Campus Libraries. So thank you all for coming to this and the other workshops. We appreciate your time and always feel free to reach out. Thank you.